It is very dangerous. We know there is PFAS, variety of PFAS in our stormwater runoff, but specifically focusing treating them is a kind of new topic. And in a few years, I'm sure there will be some initial steps. There are some initial steps also for now, but it is not standardized like total suspended solids or metals. We have more knowledge about treating nutrients and metals, but not for PFAS, for example.
Welcome to the Urbanista, where we discuss the water management challenges of Nordic cities. From safe drinking water distribution and stormwater collection to building sustainable urban living environments. Here is your host, Delphine Vassallo.
No, hey, welcome back, Urbanistas. It is so nice to be back on your ears. During the whole last year, we have followed in the news of all these unfortunate and damaged torrential rains that have provoked a lot of damage all over Europe. Flooding tunnels in Poland, small towns in Germany and Switzerland completely covered in water, overflown from rivers, and the consequent pollution. Even here in Finland, with metro stations completely flooded, with the consequent pollution of the respective water recipients. After the water goes there, what is happening? Yes, no doubt we are living tough times, but what can urban planners do to prevent this to happen in the future or to improve the current status of the infrastructure, which we know in our European cities, for the most part, is old infrastructure that we need. We have the challenge to renew. Let's start from research. And that's a big part of what we at DF Uponor have been doing, partner with academic institutions to deep dive into those problems and find concrete solutions, innovative solutions to the stormwater pollution problem in our cities. And precisely to talk about that today, we have an expert in research. So who are you and what do you do?
Hello, my name is Talat. I'm an industrial PhD student in north of Sweden in Luleå University of Technology. I'm also working for GF Piping Systems. I'm a former Uponor, now GF Piping Systems. My research focus on stormwater treatment, especially for compact treatment technologies, but research going on like all stormwater treatment options, but directly focusing on compact stormwater treatment technologies. So I'm originally a civil engineer. I started to learn about stormwater treatment systems in 2019 when I was a master's student. And after that, I continued to work in this area. I found it very exciting and crucial for our urban planners and our urban planning strategies. So this is a short story of me, actually.
Thank you so much, Talat, for being with us and sharing your wisdom and actually the results or partial results of what you have been working on. So if we start like the conversation, why we need to treat stormwater? We know that there's rainfall on all our cities, and then it's collected and going down, the respective networks. So, but before it gets to the water recipient, why is so important that we need to treat stormwater?
Well, stormwater treatment is essential for maintaining clean water systems, protecting public health, and preserving the environment, basically. As cities expand and more land is covered with impervious surfaces, such as roads, roofs, or parking lots, this rainwater cannot infiltrate the ground naturally. Instead, stormwater flows rapidly over these surfaces, picking up a wide range of pollutants before being discharged to rivers, lakes, or oceans. So one of the primary reasons to treat stormwater is to prevent water pollution.
But also when we are talking about the water recipient, that's why it's important, because whether it's the sea, a lake, a river, that in the end downstream will end up somewhere where there's population. But you also mentioned infiltration when there's no the possibility to dispose or to send the water to a water recipient. We need to infiltrate it on site or almost on site, and those pollutants, then what happened with with them?
Yeah, stormwater treatment or generally stormwater management is also crucial for reducing urban floodings and erosion in cities, in urban areas. When rainwater cannot infiltrate to the ground, it accumulates quickly, overwhelming storm drains and increasing the risk of flash floods. And in many cities, stormwater drainage systems were not designed to handle the extreme weather events that are becoming more frequent. And because of that, as a result, untreated stormwater can lead to costly infrastructure damage and maybe road closures and disruption to daily life.
So if we can go one by one, just to start to really deep dive the key
Okay.
treatment methods that you have been testing, and yes, also using several of our products. Can you take us through? I believe, you have some case studies as well. So if we go one by one of each of these treatment methods and how effective they are.
Okay. Well, stormwater is treated, first of all, through a combination of physical, chemical, and biological processes, each designed to remove pollutants before the water is discharged into natural water bodies. The choice of treatment method depends on land use, pollutant concentration, and site-specific conditions. So the site and the urban catchment, firstly, is very important to decide which treatment solutions you want to use. So in urban environments where impervious surfaces prevent natural infiltration, stormwater systems must be designed to capture and filter large volumes of runoff efficiently. So the most common stormwater treatment methods involve sedimentation, filtration and biological treatment. Filtration.
Exactly. Please. So we have biological, chemical, physical. Did I get it correct? Okay, maybe that goes into sedimentation or vice versa. So if we start with, I don't know, biological. So how you have find those things?
Well, biological treatment processes such as constructed wetlands, rain gardens, or bioswales relies on plants and microbes to break down organic pollutants and absorb excess nutrients. These systems mimic natural processes and are particularly affecting the treating stormwater in areas where land is available for that kind of green infrastructure. So if you have enough space to implement like huge wetlands or ponds, they are perfect design to treat stormwater in biological way. However, they require careful design and maintenance to remain functional over time. In some cases, chemical treatment methods, like biochemical, I can say, flocculation and adsorption and some others, are used to target specific pollutants that are difficult to remove through physical filtration alone. So sometimes physical filtration is not enough, so you have to use biological and biochemical sometimes.
We have this more classical example of this blue-green solution, which is a natural pond in, I don't know, there's an artificial pond made in any part of the city, where in the dry season is just a park or even a football pitch, and then on the rain season that becomes, or actually converted into a water depository. But because the water comes from different parts, but before the water gets there, that's what we have been seeing, that some water utilities are putting, before arriving there, they put a pre-treatment chamber or some sort of that, because once it's there, it will infiltrate, and then I guess there's no chance of filtrating or treating it further. So before getting into this natural pond, that's when you are telling it could be physical, biochemical, or how do we, where the actual filtration or treatment happens.
Okay, there are lots of case studies about it, how different stormwater treatment methods perform under varying conditions. So two widely used stormwater treatment structures are in the case like you mentioned, stormwater walls and filter chambers, because they include sedimentation unit and filtration unit. These are physical treatment methods. So before your polluted stormwater reach your biological treatment area, you have to firstly treat it in physically to create more efficient and long-term treatment management for all stormwater infrastructure. So stormwater walls and filter chambers are designed to remove pollutants through different mechanisms. While both are effective for sediment and particulate removal, their ability to handle dissolved pollutants also and maintenance requirements and long-term performance, of course, differs significantly. So if I have to be more specific, stormwater vaults are underground storage systems that temporarily hold stormwater runoff, allowing suspended solids and debris to settle before the water is discharged. It can be discharged to the water bodies or the ponds, like we talked. These systems are particularly useful in urban areas where surface space is limited because they are compact and relatively small, and can be easily integrated to existing stormwater infrastructure. By capturing stormwater underground, walls help prevent excessive runoff from entering local waterways like ponds, we told. So reducing flood risks and sediment pollution to the ponds also. So this is contributing to effectiveness of your main stormwater solution. But also,
So
yeah,
can we say then that the stormwater vault has actually a double function, acts as filtering, as treating, but also as a buffer, so to keep the water there before to manage the flow downstream. So it has both applications, treatment and controlling the flow.
because of their customizable and modular, they include different potentials. But of course, it depends how you design your treatment system. You can use stormwater walls alone according to your targeted urban catchment. What kind of target you want to treat, you want to manage. You can use filter chambers and stormwater walls separately or alone, but also you can integrate them before and after, or in other words, upstream or downstream of other treatment solutions also. So they are actually include sedimentation and filtration units. So because you can use different filtration material in their filtration units, you can use them for variety of stormwater challenge. You can treat different stormwater pollution characteristics according to how you customize them according to your problems, actually.
Because when we are talking about this bowl, those are big structures, and the capacity, I understand, it's like above that 1,000 liters per second. Processing. So you can imagine like the size of the structure that is capable to handle all those things and to filter all those things. So that's for big volumes. You are also mentioning filter chamber, which may be for smaller volumes, well, smaller, quote unquote, smaller, uh, or how is it? Where is better use a ball or a filter chamber?
Well, filter chambers are generally more small scale applications, and of course they include filtration units, but their volume storage capacity is relatively less. But with Vault, you can extend your storage capacity. So you are storing more water, you are preventing more flood, but the more important thing is you are giving inflow more time to release its sediments before filtration units. So if you know your catchment very well, and if your catchment is relatively small, you can choose filter chamber as a solution because they are small, but this can be a disadvantage for the small sedimentation unit, but at the same time you are using less space in urban environment. So if you know very well, you can use the proper filtration unit and you can use the filtration chamber in a correct way. You can create more effective stormwater treatment scenarios. But if you want to manage larger urban catchments with more uncertainty, the stormwater vault in that scenarios may become more efficient solution. But of course, all solutions depends about what kind of problem you are. So you should know what is your problem in urban catchment in terms of stormwater pollution. Firstly, of course.
So of course, immediately that will be the first step for any urban planner. So we have this area. So what is the number one problem we are trying to solve? Is it mostly treatment? Is it mostly flooding, or both? But yeah, that's the I guess the key question to start with. And as you said, We have different environments. Sometimes in cities, the space is limited because it's just what it is. Our cities are how they are. But all these solutions can be customized in size and in capacity to fit whatever they need to fit. You were mentioning also the filter chamber that has some different filtration solutions. Can we use the same interchangeable between the vault and the filter chamber, meaning sedimentation, biochemical, or is there any variant or any limitation that in the smaller you can only do physical treatment, or what would be the difference in terms of treatment between these
But
two?
between stormwater walls and storm filter chambers.
Yep.
Well, basically, they both include filtration unit, but the capacity of stormwater walls are always higher. So, in theory, you can treat a variety of stormwater pollution according to what kind of filter material you put inside your filtration unit. But mostly the bottleneck or the most critical part of stormwater treatment is when there is high flow. So when a high flow or a peak flow enter your stormwater treatment facility, it can be bypassed before going through your filtration unit, because there will be loss of flood and loss of water basically. And another challenge is leaching from filtration unit, what you have collected as a pollutant before. So because of our main challenge in terms of treating stormwater is the high flows, the limitation of filter chambers in that case is much higher. I prefer for low flow conditions and more steady state conditions. Filter chambers are better options. But in terms of uncertainty flows with high flow possibilities, the stormwater walls would be a better idea. But in terms of filtration, because of you can customize your filtration unit with putting different filter materials. In theory, their pollution prevention capacity is same, but as I mentioned before, it directly depends your flow characteristics.
You have mentioned different type of pollutants. I mean, organic debris, microparticles. Yes, so all those things are going in the stormwater. What about those are more like solid? What about oil, for example, from cars, from other machines? That's liquid. How do you have any insights about that? Filtering oils or any other type of liquids that are no water, of course.
Well, because of highly trafficked areas, for example, like highways or crowded streets in our cities, and some petrol stations, the oil always a concern in stormwater treatment. So actually, oil can come into our filtration unit, and both the solutions, if we are talking about stormwater walls and filter chambers, all of them have capacity to prevent oils, or if we talk in general, hydrocarbons. But of course, the challenges are not limited with hydrocarbons too, because hydrocarbons are more becoming traditional problems that we have been trying to solve in more years. So if I want to go into, for example, pair or polyfluoroalkenes, or in other terms, PFAS, are more emerging concerns like microplastics. So because they are newly detected, relatively newly detected in our stormwater sources or stormwater runoffs. So the main idea for now in both scientific literature and academia and industry trying to solve this emerging pollutants problems.
Do you have any insight about this PFAS, or has been that in your scope, or not?
All people in industry, when you talk about stormwater treatment, all of people are trying to understand how to treat PFAS because they are, they are also known as forever chemicals. Like PFAS originate generally from industrial processes, firefighting foams, consumer products such as non-stick cookware or waterproof fabrics, for example. These chemicals are extremely persistent in the environment and have been found in stormwater runoff, contaminating rivers, lakes, or groundwater sources. So, PFAS contamination is particularly alarming because these chemicals do not degrade naturally. This is the main problem.
So we have to treat them. There's no other way. I mean, there have been a purposeful effort to treat.
Yes, I mean,
Are we there? Are we already there, or do you know what's if there we have a solution or a partial solution for that, or is that to come in the products?
I'm planning to create a long-term monitoring program in 3 stormwater walls in Norrköping, Sweden, and we have to firstly watch or monitor what kind of and how much PFAS we have in our stormwater flow before stormwater vault, inside stormwater vault, and after stormwater vault, or upstream, downstream, or before filtration units. We have to monitor them. Before start to solve pollution, we have to understand the problem. It is not completely understood now. We know it is very dangerous. We know there is PFAS, variety of PFAS, more than 50 now detected, different types in our stormwater runoff. But specifically focusing treating them is a kind of near topic, and but in a few years, I'm sure there will be some initial steps. There are some initial steps also for now, but it is not standardized like total suspended solids or metals. We have more knowledge about treating nutrients and metals, but not for PFAS, for example, because the traditional sedimentation and filtration methods are relatively ineffective against these contaminants like PFAS, and prompting to need for specialized solutions.
So yes, that may, as you said, maybe that in the future of your PhD research. So before in the inflow, during, or while the water is stored, and then the outflow. So to really go deep diving into each stage of the process to see where the PFAS have the most impact, and okay, what can we do about that? So, but I guess yes, still work in progress, and well, maybe we need to wait for more concrete results. Or do you have any partial results at the moment that you can share? I mean, whatever you're feeling good to share.
Well, not for PFAS yet, but I finished.
For the other types of pollutants. Yeah, let's see what you have.
I conducted a fieldwork about sediment sampling for sedimentation of unit of different sedimentation facilities across Sweden. Also, in our there are some other data on literature we can compare. So, my fieldwork include 10 stormwater walls in Sweden, and also other sedimentation units, for example, for biofilters. And the initial results show that the sedimentation units are accumulated sediments according to urban catchment directly. So, for example, there is highly urbanized catchment you are getting finer particles. Actually, this is good because finer particles in sedimentation unit means your treating performance is better, because these pollutants are attached with finer particles, and they are moving in stormwater runoff with this mechanism. So when you have ability to catch finer particles, that means you have good step in treating metals and other emerging contaminants like microplastics, PFAS. But This my first project was directly focused on sedimentation. So it is just one step of treating stormwater in that stormwater walls or filter chambers. Of course, when the general area of stormwater treatment facility increase, the sedimentation performance also increase because you are giving inflow more time to release from its sediments into your sedimentation unit. And the other outcome is the maintenance is extremely important for treatment efficiency. The systems are not miracle. I mean, you cannot implement or install them to your existing stormwater infrastructure, and you cannot solve all your problems immediately. You have to care of them. I mean, you have to maintain them regularly. You have to know what's going on inside them. If you don't if there is no maintenance regularly, or if there is no maintenance plan periodically, that means your sedimentation unit reach its capacity fastly, and after a high flow, all sedimentations you had been collected in your sedimentation unit become to release or become to outflow from your vault. So, in summary, two main outcomes are the maintenance are very important, maintenance programs generally, and
Do you have any insight on this? I mean, talking about maintenance. So, how often or what's the period like ideal? Well, of maintenance of this couple of products that we have been discussing.
well, it depends how many sediments are you collecting for a certain time. So, for example, it depends if your targeted catchment area is 1 hectare or 5 hectare. It directly affects your sedimentation unit's performance. So I cannot say, like, for example, you have to maintain your sedimentation unit every 6 months, because if your catchment is relatively small, your maintenance period can be larger. But in my observation from site, at least every year it should be completely cleaned. I can say that.
Okay. Okay. Yes, as you say, it has a lot of dependencies that the ones that you mentioned. That well, they mean one set of time that, but at least once a year, we are well, for sure that yeah, at least an inspection, and then whether we proceed with the maintenance, the cleaning of the filter material or not. Well, but at least we need to go and or the technical people need to go and see it there. So that is clear. You have mentioned that besides the filtering methods that you have been testing already, you may be exploring new things. Do you have anything to share about these new other solutions, other filtering or treatment solutions that you have been exploring?
My focus is directly on stormwater vaults, or
Mm,
in general names compact technologies, but we can talk about exploring other solutions, of course, because this not a field you can focus just one solution, because the problem is not single. So you have to be aware of other possible solutions too. So if we mention again like blue-green infrastructure, uh, these are basically integrating nature-based solutions into urban environments. So uh, green, we can talk about in terms of blue-green infrastructures like green roofs, with constructed wetlands, rain gardens. And one of the most significant benefits, of course, for blue-green infrastructures are stormwater retention, pollutant removal, and of course some others we have been talking about.
Okay, yeah, there's like wide variety of solutions, and as you said, um, your research is ongoing. There's no definitive results yet, and even once you finish, you say, okay, it depends where it is, the concrete situation, the concrete circumstances in which the solution is installed. So that requires yeah a lot of in-depth research. So if we start to summarize yes, it's super important to treat stormwater for, not to pollute the water recipients. That's one, for that's kind of obvious, but also what comes to treatment on site, in terms of infiltration, that is also maybe overlooked sometimes. But we understand it's an ongoing work, and I guess it will take still a few months or years to get more concrete things from your research.
Yeah, I mean, during the research, it is not very easy to directly say something like, I found this and we have to do this. So, because it's an ongoing process, you are completely right. But for final thoughts, stormwater management is evolving to address new challenges, including urbanization or emerging contaminants, such as PFAS, we have been told about. And while traditional methods are effective for removing sediments or nutrients, they are sometimes relatively insufficient for persistent pollutants, which require advanced treatment technologies. So, previous case studies demonstrate that the hybrid systems combining filtration, biological processes, like your example, ponds and filtration units, create more effective solutions. So, also, in general, blue-green infrastructure presents a promising alternative. So all of them are part of blue-green infrastructure for all possible solutions. So they are offering multiple environmental and social benefits while improving stormwater retention and quality at the same time. So looking ahead, stormwater treatment must adapt as stricter regulations and evolving pollution concerns. So maybe future developments should focus on more scalable, more cost-effective, and more resilient treatment technologies to ensure cleaner water and urban environments. I can say that for final thoughts.
All right, so there you go. So thank you so much, Talat, for sharing partial results we have from your research. But anyway, it's encouraging to see how much work has been done, how much we have achieved in this field. And since this is an ongoing process, an ongoing job, well, I may commit you already. I mean, in few months, or I don't know, to come back and share what else have you found in these times. So to get an update for the Urbanistas. So thank you so much, Talat, for sharing this, and for you Urbanistas, more conscious, more being aware of the true value of stormwater treatment. So thank you for listening today, and see you next time.
Thank you for listening to the Urbanista podcast, a production of Uponor Infra, the leader in sustainable infrastructure solutions. If you found it interesting, why don't you share it with your colleagues? We all together can move our industry forward.